Hi, my name is THONG and I would like to introduce my group members first. They are YUAN, Wenjing, and KANG. This video is the final presentation of PITS 1313 Data Communication and Networking Project. First of all, I will explain about the OSI layer model. OSI layer model is called Open Systems Interconnection Model. It is a model which describes 7 layers of communication over a network between computer systems. OSI layer model contains of 7 layers which are application layer, presentation layer, section layer, transport layer, network layer, data link layer, and physical layer. Data from sender side will travel from application layer to the physical layer, while data to receiver side will travel from physical layer back to the application layer. In the application layer, from student's computer, user can log in via student email address and password. Files which has been uploaded will travel to the next layer, which is presentation layer. The data is now in presentation layer and will be translated and compressed. Next, the data will go to the session layer. At session layer, management is open and the conversation between student's computer and YUAN application is closed. The interaction between student's computer and YUAN server will be synchronized. Next is the transport layer. This layer receives data from the upper layer and performs segmentation. The data were transported by TCP, which is also known as Transmission Control Protocol. TCP has built-in systems to check for errors and make sure the data will be delivered as the order as it was sent. Then the data will travel into the network layer. This layer will use logical address to communicate between student's computer and YUAN system in different networks. IP address of sender and receiver are also added so that each sent packet can reach its destination. Then, the data will move into the data link layer. In data link layer, the encapsulated information will be converted into a digital signal and passed to the physical layer. Physical layer will convert the digital signal into analog signal and put them into the physical medium.
In this class, I will explain data transfer to YUAN system server. First, we'll go to physical layer. UTM IT Center will get the signal retrieved, convert it into digital signal and send them to the data link layer for further processing. Then we'll go to data link layer. In this layer, we'll organize digital signal into frames and correct faults at the physical layer to ensure that data flow is error-free, then transmitting frame to the network layer. In network layer, the network layer is not needed when both the systems are connected to the same link. It then resemble the data packets into segments for the upper layer. Then we'll go to transport layer. In this layer, the transport layer will perform the receivability and sequencing of data. It reads the port number of the data from the header file and then direct it toward the proper application. Then we go to section layer. In this section layer, the YUAN server in IT center perform name recognition and the functions such as security need to allow students' computer to communicate over the network, also provide error handling. Then we'll go to presentation layer. For this, YUAN server in UTM IT center will retrieve all the information and data from students. Then the YUAN system will execute the data encryption and text compression. And the last will go to application layer. The YUAN server in YUAN IT Center will retrieve all of the data from presentation layer. When the data reaches, it means that the data transfer from student computer to the server is successful and complete.
Subnetting calculation. YUAN network is using Class C private addressing scheme, which is 192.168.1.0/24. The default subnet mask is 255.255.255.0. At YUAN, there are 8 different faculties. To subnet to 8 faculties, we need to use this table. In this case, we will use 2 power of 3 as our number of host bits, since 8 fulfill our requirement. So that 255.255.255.224 is the new subnet mask. We get 224 by adding 128, 64, 32. Since we borrow 3 bits from the host. Then, our new network number will become 192.168.1.0/27. The new subnet mask will become 255.255.255.224. Class type remains C. Number of host bits available is 8. Number of host bits borrowed is 3. Number of hosts remaining is 5. Number of hosts per subnet is 30. By using this formula, 2 power of hash minus 2. The new prefix is /27. Based on the table below, add the 5th available subnet and 5th available address. The YUAN system server IP address is 192.168.1.166.
In this part, TCP/IP setting manual, we are going to show you how to configure the IP address on the servers. First, press Win R, type the control panel, and click the OK. After open the control panel, click the Network and Internet. Then, click the Network and Sharing Center. After open the Network and Sharing Center, your internet connection will be appear. You may use the either Wi-Fi or Ethernet. In this example, I am using the hotspot as my Wi-Fi, and click the Wi-Fi schedule. Hence, click the properties. Thus, double-click the Internet Protocol version for TCP/IPv4 to open the properties. Change the setting from obtain an IP address automatically to use the following IP address. Then, enter the IP address, subnet mask, default gateway, preferred DNS serve, alternate and DNS servers, and click the related setting open exit. After that, click OK. Then the Windows network diagnosis will pop out will appear to check the whether there is no problem with the new IP address configured or not. If not, press the close button. Initial, you may test your internet connection. If you can access any website, it means that your configuration of the IP address was successful.